2:15 from the homework. Go ahead and read it to me.
Y equals negative x squared plus 2x plus 10, and the other y equals x plus 4.
X plus 4. I'm going to go ahead and solve this using the calculator first. I know the homework said substitution, but I like us to use the calculator to check our answers, okay? So I don't mind solving it both ways. So go ahead and plug this into your calculator. Let's graph it. Let's make sure we know how to graph it. We see an upside down parabola as our first graph, and I see a line as our second graph. So we'll go ahead and plug this up. Let me get my calculator up here. There we go. And we're going to go ahead and plug in negative x squared plus 2x. Let's move this out of the way. Plus 2x plus 10. And then if we go to the second one, I see x plus 4. All right. Let's see. We'll go ahead and hit a graph. We'll see a picture. We have our upside down parabola. We have our line. And I don't even have to adjust my window because I can clearly see the 2 points of intersection, right? So no problem. So all I have to do to do it quickly on my calculator is go to second, trace. We're going to find the intersection. And I don't see my flasher die. It's kind of hard to see, but if I look down here, I see it at the point 0, 10. I'm going to move it kind of closer to one of the points. You see how it's closer down here to the bottom now? And I'll just hit enter literally 3 times. So negative 2, 2 is one of the answers. And then I'll go to the other side and do the same thing. So I'm going to go to second calc. Again, intersection. I'm going to go to the other side, so I'm closer to the other point, and hit enter 3 times. So I have 3, 7, and negative 2, 2. So I know ahead of the game what my answer should be. Okay? So let's just write them down so I know. Negative 2, 2, and what was the other one? 3, 7. Good morning, sir. You have to go on. Any other things? Okay. So let's kind of look at how I could do this problem using substitution. Because that's really what the homework asks you to do, right? Alexis?
We use the calculator. Couldn't the first number of the 2 solutions could that help us faster?
Absolutely. That's a really good, we use the that's a really, really good point. If we know what the solutions are ahead of time, and I'm trying to do this by a substitution, she's right. These 2 numbers should help us factor it. Great idea. Okay? So what we're going to do here is we're going to use our substitution by setting them equal to each other. And this is what a couple of students came in this morning, and they were like, well, I got everything to one side. But in this case, we have to be very careful about the side that we want to move everything to. So what did I tell you that I want everything to go to?
Positive. You want the negative squared to be positive.
Go right. We want everything to go to the right because we want our leading coefficient to be positive. We want this number here to go to the right. So we're going to move everything to the right side. Okay? So I'm going to add x squared.
Wait.
Because I don't want my first number to be a negative. If this was a positive, I'd move everything to its side. Okay? You move everything to the side that will make the leading coefficient positive. That just helps us factor easily. Okay? So I'm going to move now the 2x to the other side. I'm going to move the 10 to the other side. So that just leaves me with a 0 on the left. Now, I have to be careful about what I can combine versus what I can't combine. So I'm going to color code things. The x squared has nothing to combine with. The x and the negative 2x can combine, and then the 4 and the negative 10 can combine. So we just have to combine like terms. Okay? So at this point, I have x squared. I have minus 1x, and then minus 6. So at this point, I want to factor. And I'm looking for the 2 numbers that multiply to be negative 6 and add to be negative 1. And here's where what Alexis suggested really comes into play. If I know the answers ahead of time, because I checked it on my graph to start with, I know that I'm going to be using 2 and negative 3. Remember I changed the signs? So So I know that if they multiply to be -6 and add to be -1, I'm going to have -3 and +2. Notice how those are just the opposite signs. That will always happen. Nice. So I'm going to factor x minus 3x plus 2. I'm going to set each of those factors equal to 0 and solve. Okay, so I get x equals positive 3. That's not a coincidence. And x equals -2. Not a coincidence. Yes, ma'am.
If we're on the test, do we have to like do all the work, or
Yes.
if we know those?
If I say solve by substitution, I want it all. Okay? But on an SOL, they're not looking for work. What are they looking for? The answer. And so that's why I show that to you. Okay? Because I want you to know how to find the answer. Yes, sir.
Well, you have the highlighted, that's the answer, right?
That's what you should get here.
So what would the answer be, the exit
I'm not.
or
Okay,
the
so
point?
let me finish. Okay. I started here only because I wanted to make sure we had the answer. Okay. So what's highlighted is the same thing as what we should get here. Now, that's not the full answer. This x equals is not the full answer. The full answer are the 2 points. Okay. So we started with the full answer. Okay. We need the actual answer are the points of intersection. So Gabby, we were going to say I'm looking for a full point, right? So how? I'll give a question to you. Go ahead.
No, I'm just gonna say, so if when we end up with the x equals 3 and the x equals
-2.
-2, find it.
That's where I'm headed. How do I find the y coordinate? I plug them in. Where do I plug them in?
So the y equals x plus 4.
Right. Any of the two at the beginning are fine, doesn't matter. But I agree with Chris. I happen to think if you plug it in here, it might go quicker for you. Okay, it's pretty easy to plug it in. So I am going to do that. I'm going to plug in a 3 into here. So y equals 3 plus 4. Well, that's just 7. So that's where 3, 7 came from. Now I'm going to plug in the -2. Y equals -2 plus 4. Well, that's just 2. That's where the 2 came from. Okay? So we should be able to solve with the calculator, solve using substitution, and we should get the same answer. I took these two numbers and I plugged it into that equation. Well, I can plug it into either one of them, doesn't matter. I picked the easier one though. Everyone learned it last year. All right. Yes, sir. No. Okay. Because when I plugged in a 3, I got a 7 out. So the 3 goes with the 7. Moody's question is an awesome one. So I really want to make sure that Shamar is awake and listening. Okay? You ready? He said, what if, and several people did this on the classwork last time, what if I mixed up the y's? What if I said -2, 7 and 3, 2? That would be wrong. Let me tell you why. Because when I plugged in the 3, I got a 7 out, which means the 7 goes with the 3. Okay? When I plugged in a -2, I got a 2 out, which means -2 goes with the 2. Okay? Awesome question. How do we feel about the homework now? Feel good? All right, you're going to have a quiz coming up on it. Okay? Feel good about the quiz? The quiz is going to include what we're going to do today, though. Okay? So next class, you can expect a quiz on those two things together. Not next class. Next class I won't be here, but it'll be the class after that. Yes. Huh? I'll be in the building, I just won't be in this room. I'm in a 2-day, full-day meeting. Go ahead. Is it the 16th? Okay. Here's what I need for everybody to do. I'm going to combine and we're going to go ahead and be graphing some linear, some inequalities, graphing some stuff. So we're going to, for a few minutes, we're going to play with markers, okay? So let me come by and give you a neat little graph thing, okay? We got these the other day, and I really like them because you get your own. We don't have to share. They're brand new. You have your own marker and everything. They're really thin, so just make sure you only have one. Can you just double check that you only have one with you? Alex happens to have 2. Okay.
That's fancy, you got the donuts.
Are you ready? All right. So what I want us to do is practice graphing quadratic inequalities. We know how to graph quadratics, but we're going to add a step to it for just a couple minutes today before we move on to the modeling stuff. And we're going to graph an inequality. So here is the problem that would be given to you. Okay, it's a system. ones that we did before. So I want you to have the graphing side up. Hang on, Christian has his hand up. What is different? What sign? Right, the greater than or less than signs. Okay, they're not equal to anymore. Do you remember on our calculator what we did first quarter? Well, be careful. No, we didn't. We ran an app. Do you remember that? Can we go turn that app back on your calculator, please? And then we'll turn it off when we're done. But when you see these inequalities, I want you to turn that app on.
How do we go through?
Go to apps.
When I was going through my delinquency, I thought I used that.
So I'm going to show you right now. Go to apps. Now, you don't have as many apps as I do, but if you just go ahead, yours might already be running, and that's okay.
It's gone.
Okay, this is gone.
I don't
Give
make
it back.
sure. I don't even check.
Hang on. This one right here, inequalities. I know, I just said, you're listening. I have a lot more apps than the rest of you. Most of you have 2. That's okay. All you need is the inequalities app. Guys, please listen. There's only so many apps allowed on the SLL. This is one of them. That is why I'm allowing you to use it, okay? The problem with this inequalities app is that you don't want it running unless you have inequalities. So we're going to turn it on, and then we will turn it back off, okay? So for now, until I can get it on your calculator, just borrow one of mine, okay? All right, so let's turn it on. Hit enter, and it should go ahead and be on. Press any key. If you notice, what happens when we turn the inequalities app on is now all of a sudden you have these inequalities at the bottom. Remember this? Okay? We're going to turn it off when we're done because we don't want them there all the time. We only want them there when we have inequalities, okay? So let's clear out what's currently in the calculator. And if you go over and highlight the equal sign, we want to change it to what? A less than. So we're going to look at our options across the bottom, and we're going to put in a less than, which is if you just hit the alpha, sorry, you're going to hit alpha window, and it changes it to a less than sign. So hit alpha window, and it should change it. Then you just go ahead and arrow over and type in the rest. Now, I'll be showing you this on the smartboard, but I don't think that my smartboard calculator has this app on it.
So what does alpha 1 mean?
How do you get that?
Alpha 1, alpha window. And then if we're going to do the same thing on the second one, you have to make sure to change it that you arrow over and highlight the equal sign. And this time, it's a greater than symbol. Greater than is 1, 2, 3, 4 buttons down. 1, 2, 3, 4 buttons down is the trace key. So we're going to hit alpha trace to get that to change to a greater than. Okay? I only want to graph one at a time first. And so if you plug them both in, it'll plug them both in. But we're going to plug in the first graph. If we graph only the first one, let's just look at what I have here on the board. I want you to try to graph it with your whiteboard. Okay? So, well, we'll graph the whiteboard in a minute. Just hold off on the whiteboard. Okay? We're going to graph the first one. Does it make sense that it's upside down parabola?
Yeah.
That's a negative. Does it make sense that it's dotted?
Yeah.
Why?
Because it's not equal to.
It's not equal to. Does it make sense that it's shaded underneath?
Yes.
Why?
Because it's less than.
Good. So all those pieces click to me. We know it's upside down, we know it's shaded underneath, and we know it's dotted. Okay? Because of the way the equation looks, or the inequality looks. Because it's a system, we're going to graph both of them. So once I've graphed this, now I'm going to graph a separate parabola. What do I expect this one to look like? Right side up, shaded above, and still dotted. So hopefully, when you graph it on your calculator, you get a similar, oh, what happened to mine? You need to go to standard. I am zoomed in from a box that I might have chosen early on. And this probably will happen to you at some point. So if you have a strange window like this, to get back to the original one, you just go to zoom in. Zoom 6. Now I still don't see everything. My picture on my calculator doesn't exactly look like this one. Can you tell me why?
Why is
Mine only goes up to 10
That one's like thicker.
for the Y.
Say it again,
Oh,
Christian,
It
louder.
only goes up to 10 for the Y.
This Y goes up all the way to 20.
Why do you have them shaded and mine don't?
So some are shaded, some aren't? Okay, so we'll have to look at that. Okay, I need to make my Y taller first, then I'll help you with your calculator. If I go to my window and I make my Y taller, Y max, I'm going to go up to 25 just to be on the safe side, and we should see everything. Here's my question. What is the answer? The whole thing is not the answer. There's only one
What did they
little
even
piece.
say?
Okay, so here's a question I can see on the SOL. You ready? Click on the part of the graph that is the answer. You know how they make you use an arrow on the SOL? They make you click first on the graph? So where is the answer? Christian, you want to help us out?
It's where the like shaded in.
So if I look at here, it's where it kind of looks like a crisscross pattern. Wouldn't you agree?
Yeah.
Only where the both lines cross. So I'm going to highlight it here. Now, if I were you, and this is what you're going to do with the dry erase boards in a minute, is you're going to erase the parts that don't count. But this right here, yellow's not going to work. Yellow won't even show up. Let's try a different color. Okay? Let's make it a skinny line. This right here is the only part of the graph that is the answer.
Wow.
That little skinny thing.
Unlike anything.
Okay? That's it. The graphs overlap is the answer. So on your dry erase board, we're going to physically erase the other parts. Okay? Let's try one. Okay? So here's one for you guys to try. All right, so here is your system. Okay? Notice that one of those parabolas is going to be dotted. One of them is going to be solid. So I want you to be careful about your graphs. So go ahead and you can use your calculator to help you start. Excuse me. But then I want to see your answers. You might have to graph it this way, so it's taller. Okay, you might want to change your graphs to this direction. So there's a kind of a hit there. So to find the exact points to graph on your own, you go to the table, and you're going to look. You see you have one set of X's and two Y's. I'm going to really just cover up the Y2 right now, and I'm just going to graph the points from X to Y1. So I'm going to graph the point -3, 0. I'm going to graph the point -2, 2. I'm going to graph the point -1, 6. And then we have 0, 12, which is kind of off of mine, so 11, 12. So it'll be up here. Okay? And if I go on the other side, if I just kind of go up on the other side using the parabola, we have -4, 0. And then we have -5, 2. So we kind of get the idea. It's a solid parabola, so I'm going to make it a solid one, and I'm here. Okay, that's the first parabola. The second one, I'm going to graph it a different color. And I'm going to cover up the middle column on my table, Bradford, and I'm going to go ahead and just do the first and the last. Because I can see your eyes. I can't see. This is why I'm talking. Because I'm taking. Because I want you to hear me. -5, -8 is the first one. And -8. So we're here. Then we have -4, 0. Then we have -3, 6. Then we have -2, 10. And then we have 0, 12. Okay? This one happens to be a dotted line. Wait. And I'm just going to kind of go on the other side. Because I really don't care about this. What I care about is where they overlap. So the answer is simply only going to be this right here.
How would we like? Is there a certain way to answer? Like say something?
No, all you can do is graph it.
Oh, that's not bad.
That's it.
Oh, never mind.
So it looks to me like just about everybody got it.
So if we
Almost.
have
But shade in. We got the shade
Oh,
in.
but it's right.
So far, we got to finish by shading.
You know what, bro?
It looks real
You're
wrong.
a real easy.
Are we okay? All right, let's back.
so compliment.
All right, yeah, go ahead. That's fine. You guys did a good job. Go ahead and erase your boards for me. Okay, we're gonna put them away. I just wanted to practice one time. Okay, if you would, come put your supplies back for me.
That one.
That just sounds like a
So a lot of people, what we're about to do is called quadratic modeling. And any kind word problems always freak people out. But I'm going to try to break it down as easy as I can for you so it's not difficult.
Is this
Okay?
a real life situation?
This is our real life situation stuff. Okay?
Should I take my notes out?
I would.
Alright.
I would, because there's going to be a lot of calculator steps, so I would recommend that you write those down, okay, so we're ready to go and you're not at home going, oh, I forgot what to do, et cetera, okay?
Oh, I should have already written notes. Alright.
All right. So, modeling is just a way to use math that describes a real life situation.
You write that down?
You don't have to. I'll tell you what to write down. when we get there. Okay? So, there are lots of different situations that can be modeled by a quadratic equation. And here's one I know Tim will like. Path of a ball can be modeled by a quadratic equation. Okay? Here's the thing, and this is a common one. If I threw a ball up into the air and have it come back down, believe it or not, that's going to be modeled by a quadratic equation. The height of the ball versus the time it takes. So if I had a stopwatch and I threw the ball in the air and I started it, the height would increase to a certain point. Would you agree? And then at some point it comes back down. Isn't that a parabola? Right? Goes up, comes back down. And it's modeled over time. Okay? So that's one example. There are many examples that can be modeled, but we'll look at several of those situations. Tides, back and forth. Actually, those are more of a sinusoidal, but anyway. There are different types of equations, different types of mathematic equations that model different situations. Today, we're only going to focus on quadratic models. Okay? So we already did. All right, so let's look. So let's talk about a ball again, like I said, a thrown ball. Okay? And it says we have it's a big word, parabolic. But what word do you see inside of it? Parabola. So you know what that means. But if you hear the word parabolic, that's what it means. You know what else is parabolic? Anyone have a satellite dish at home? Okay, some people do have like Dish Network or what's the other one? DirecTV. Okay, that is actually a parabola. It's called a paraboloid. It's a 3D parabola. Huh? Okay, anyway, I'm just giving you examples of what parabolas are. Okay. Here is a table of values. Guys, come on. Table of values. When you get your classwork for today, sometimes you'll see them in a table. Remember, we can write this table a bunch of different ways. Let's go through all the ways we can do it. You ready? So I can look at this particular table and write it as a 0.13, couldn't I? Couldn't I write this as the 0.25 or the 0.36? Would you agree with that? Yes. Sometimes you're given points, you can write them in a table. There's another way to do it. Look at this weird way. Ready? I know that f of 1 is 3. When I plug a 1 in, for my input, my output's a 3. I can say f of 2 is 5. I could also say f of 3 is 6. All three of these happen to, we have a mapping one too. I don't know if we can have that here, but I could. Where you have x's and you have y's. Hang on. And I have 1, 2, 3, and I map it to 3, 5, 6, and I can map it. So aren't all of these really just 4 different ways to show you the same points? Okay? You need to know all 4 of them, okay? Because you might see them written in all 4 of those ways. Someone said this is better. Yes, ma'am. F of, what is this here? That just means function. This is just the function notation. That's all that means. It just means I plugged in an x, I got out a y. Okay? So the number inside the parentheses is your x, the number outside your y. That's all. Your input versus your output. So you might see the points written in all these variety of ways, and it doesn't matter. Okay? Let's read the question though. It says the top of the wall is at the 0.56. Will the ball go over the wall? Or will it hit the way down? How far up do I have to go? Another question you might see, which I think is a better question, is what is the highest point? Okay, I like that question better. What is the maximum height of the ball? This is a problem I write down, by the way. Okay, maximum height of the ball. I like our question better. Okay, let's do my question. What do you want to? I want you to write the correct. Here, I'll highlight what I want you to write. Here, parabolic path of a ball can be thrown by model by the table. Write the table down. And then I want you to write the two questions I'm about to write now. Okay? Because I think these two questions are going to be better to write. Better questions than the ones we're given in here. Okay, so just write what I've highlighted. What is the max height of the ball? When does the ball hit the ground? So I have two questions I want to answer. I'm throwing a ball up, and I want to know how high the ball is going to go. If it passes through these 3 points, the point 1, 3, the point 2, 5, and the point 3, 6, how high does the ball go? And when does it hit the ground? So we have to ask some questions here, okay? We have to say, what things am I measuring? Well, I'm talking about the height of the ball, and I'm talking about when. When is a time situation, don't you agree? So we're looking at the height and time. Time is always going to be your x, and your height is always going to be your y. Okay? So time and height. So when we're looking for max height, am I looking for an x or a y value? Y, because it's a height. When does the ball hit the ground? Am I looking for an x value or a y value? Okay? So height and when are key words. It's important to know what you're looking for. Am I looking for an x? Am I looking for a y? Before we can even answer these questions, though, we have to come up with an equation. Okay? So we have to find the quadratic model. And that's what we're going to do. Oops, let me use purple. The quadratic model. We need to find the equation. So there's a way to do it algebraically, but because we're just in regular algebra 2, I'm going to show you the shortcut on the calculator. If you were taking pre-IB algebra 2, or if you were taking algebra 2 trig, you'd have to do it by hand. Okay? But I'm going to have us just use the calculator.
What does that mean?
We're going to write the equation. In just a minute.
So what's the
Okay?
trig part about it?
The what?
The trig,
We don't do trig.
but there's the algebra 2 class right here.
Algebra 2 trig means you do 3/4 of algebra 2. So everything we do, they do it in 3/4, and they have a whole quarter of trig, not a trig. All right. Anyway, so here we go. Quadratic model. You ready? On your calculator, so that's what we're going to use. We're going to go to. So what you need to write down is these calculator strokes. Ready? We're going to go to Stat and hit Edit. All right. So I'm going to write these down. So now we're going to go to Stat, Edit. Okay. Now, in my Stat Edit, it's going to look very different from your Stat Edit. I need you to find where it says L1.
You want us to quit the app?
Oh yeah, thank you very much. Can we quit the app first? So if you go to apps, let's quit the inequalities app, guys. We don't want that on
How
there.
do you quit it?
Go back to apps and go back to inequalities. And let's quit that first. Thank you very much, Chris. You're exactly right. Hit inequalities and then say quit. And just push enter and it'll quit it for you. Yeah, we should quit it because we're done with that. So we want to stop it and start it. Start it and stop it.
Where's that?
All right, stat should be in the middle, kind of up in the top left. Or like right in the middle of the top, really.
Oh, I see.
Stat and then edit. You want to find your L1. You might have to clear your list 1 and list 2. If there's anything in, like I have a bunch of numbers in mine. Do you? You may or may not. Depends on who used your calculator previously. I have numbers. Tim, you clear yours out. And to clear it out, you have to go up and highlight it. And press clear enter. And it will clear out the whole list for you. If you have numbers in your list 1 or list 2, you need to do that. So I'm going to arrow over and I'm going to clear out all of them just because I don't want any numbers there to distract me because I think they're messy. Okay? So I want you to always use list 1 and list 2. Only because if you become a creature of habit and you use those 2 lists, it will help you in the long run. Does anybody not have an L1 and an L2 across the top? You're not even in L1. You Make sure it says L1, L2 up there. L1, L2. Just making sure. You go up to L1 and press clear, enter. Right, everyone got the L1 and L2 clear? You good? Okay. So now what I want us to do is I want us to type in the X values into list 1 and the Y values into list 2. So you're going to type in 1, enter, 2, enter, 3, enter. And you're going to arrow over, and you're going to type in 3, enter, 5, enter, 6, enter. So once you clear it, then you're going to enter your X into L1 and your Y into L2. Okay? Good so far. Now, when we're trying to find the equation that goes through these points, maybe it's a good idea to see the points first. So let's graph the points just to see it. You don't have to do this part, so I'm not going to write it on here. Or I can write it in a different color up here on the right. But you can watch me if you want. We're just going to graph it for a minute. So I'm going to make sure there's nothing in my y equals. So I'm going to clear out my y equals. And I'm going to go up and I'm going to turn what's called plot 1 on.
Remember, we're going to turn that off.
You got to turn it off a couple of times. I'm going to turn it on. I'm going to do a stack plot is what it's called. You don't have to do this, but if you're interested, you can go to second y equals, which is called stat plot. Second y equals, and plot 1 we're going to turn on. Notice there's several types. I want that first little type that looks like this. That's called a scatter plot. L1, L2, and then you're going to zoom stat. Okay? So if you wanted to graph it, that's how you graph it.
What is it you're asking us to do?
I'm asking you just to watch. I don't want you to graph it.
Are we answering those 2 questions?
In a minute, you will. That is our end goal, is to get those 2 questions answered. This is all we have to do to get there. Zoom stat. I think it's an option 9.
What is that last thing right there?
Zoom stat.
No, on the red writing. That's on the...
And Y into L2. Wait. Ooh.
So you ever get hungry and something?
I see 3 points. Do you? Do you see those 3 points? Okay. Can you kind of vision a parabola going through those 3 points? Maybe? So we got to find the equation that goes through them. Here's how you find the equation. You ready?
How do you say equation?
All right, so to find the equation, sometimes we call it the model. So if you ever hear find the model, it means the equation. I'm going to say it one more time because someone in this class is not going to know. If it says find the model, it means find the equation. Raul. Okay, just making sure that your ears are working even though your eyes aren't. You need to go to stat, over to calc. So hit your stat and hit your calc. Stat, arrow over to calc. Stat, arrow over to calc. Do you see an option there that makes sense?
You said an option?
What option looks best?
Quad reg.
Quad reg. Okay? Because it's a quadratic regression is what this is called. So option 5, quad reg. Okay? Now, be careful. You need to make sure that your X list, what list do we put our X's in?
L1.
L1. So I gotta tell mine, because mine doesn't say L1.
L3.
Okay, does yours say L1?
Yeah.
Then you're good. Does anybody say not say L1? Okay, so look at me. L1 is second 1. I need to change it. So second 1, change it to L1. Arrow down. And I need to tell the Y's I put in list 2, second 2. Then we're good, as long as you've done that. Okay? And then you arrow down to calculate and hit enter. So we go to calculate this. Yeah, calculate, hit enter. It's going to, now look here, it gives us an A, or B, or a C. We know what A, B, C means, don't we?
Quadratic.
It's a quadratic.
Well, we just
Put out to calculate and hit enter. It gives us the equation. Here is the equation. Let's put it in. It is y equals negative 0.5x squared plus 3.5x
So we gotta put that in as y.
plus 0. You're going to do that. Yes, Tim. What
What was the number that you?
How do you put that together like that?
Because if I look at the equation, A is the number in front of the x squared. B is the number in front of x. C is the number by itself. Don't worry about that r squared. It doesn't mean anything to us right now. Okay? Just worry about A, B, C. Okay? A is your quadratic term, B is your linear term, C is your
Wait, so that,
constant. That's the equation.
but that's not one of the answers.
Not yet. We have to use the equation to get the answer. Oh, we're headed there. Italian.
Does it matter if we don't have that R squared?
No. The r squared is we're not going to use it right now. So if you don't have it on there, it's a setting is off on your calculator. It doesn't matter. Okay? Now, Tim, what'd you say? We're going to put this into what? Sam?
Actually, that's quadratic formula.
No, you didn't. You said we're going to plug it into the y equals to my calculator. That's what you said. So let's go to y equals and let's do that. Can we do that? Let's plug it in. So I'm going to plug in negative 0.5x squared plus 3.5x plus 0. You don't have to put the plus 0 at the end, but you can. And hit graph. It should hit through those points. Okay? Does it look at a problem to you?
Wait, Eddie, what did you do?
Hit y equals and just plug in the equation.
I just realized something. It could, if you think about it, it kind of looks like the function, the pair function that kind of goes like that.
Here, mine goes straight.
You can put the square in it.
Yeah, how come my graph came out different than yours?
It shouldn't. Anybody else not have it working? Okay. So, my graph, because I zoomed stat, is kind of zoomed in around my 3 points. I actually like it if you zoom standard a little bit better. So let's go to zoom standard here just to see it a little bit better. And there's a reason why I like zoom standard here better. Because I can see the maximum height. I can see when it's going to hit the ground. Okay? So I want you to zoom, create a window that allows you to see both of those, because that's how we're going to answer the questions. Okay? We're going to look at our picture, and we're going to say, what is the max height of the ball? Zoom standard level. I'm going to use some algebra 2 vocabulary. Do you see the vertex?
Yeah.
What is the vertex?
It's at the top.
How do I find it on the calculator? Calculate. Is the maximum or a minimum? Let's calculate the maximum. You do it now. That will help us answer the first question. What is the max height of the ball? Okay, so let's watch. Go to second. Calculate. Because it's an upside down parabola, we're going to calculate the maximum. We have to go to the left and to the right of the highest point. Right now it's on the left. I'm going to move it to the other side to get the right. Keep on going. Just keep swimming. Put that
I
on
got
the other side.
6.499 and 6.125.
I got 3.5 round and 6.125. Now, I agree. That is the vertex. Here's the question. Only one of those heard both answers. I heard X and I heard Y. Let's go back up because we wrote it here. X was time, Y was height. So which one is it?
Y.
So what is the maximum height? 6.125.
I just exited out. So can I just run to six?
No, consider what you have. So the time would be X. The time would be X. Here's another question I could ask. Are you listening, Tim? Put your phone away.
Wait, what did you buy the answer?
I'm not there yet. We'll get there in a minute. The vertex, Shamar, come on. The vertex tells us the maximum height. If the question was, when does the ball reach the maximum height, what answer would you give me? What number would you give me? No. 6.125 is the maximum height. If I said when is the maximum height, the answer would be 3.5 seconds, because that's the time. When is your X, the what is your Y, in this case the height. Okay? So, here's another question. Height maximum means vertex. Second question that we have to answer today. When does the ball hit the ground? It is not 3.5. 3.5 is when it gets what? To the top. When does it hit the ground?
When it touches the x-axis.
When it hits the root or the zero. So now we have to find that sucker all the way on the other side. All right? So how do we find the solution? Well, I could factor it. I could use the quadratic formula.
Zero. Oh, so that's
Oh, that's how we
You
find
could,
it.
or you could use a calculator.
That's how we find when it hits the ground.
Yes. If it's an integer, you could use a table. Let's go to the table. Is it an integer? I don't know. Go to the table. Let's see.
I don't know, hit zero at zero.
Well, 0, 0, but that's where it starts. It's going to start starting from the ground up.
Maybe 7.
Let's see. It actually is an integer. Now, is it always going to be an integer?
No.
Most likely won't be an integer. So how would I do it? So good start. Good thought. Okay? Excellent. We know the answer is 7. After 7 seconds, the ball's going to hit the ground. Okay? The table told us that. But rarely will it be an integer. Okay? So how do I do it if it's not? Let's just refresh our memory.
Alright, let's do some factoring.
We could. If this one happens to factor, I'd rather quadratic formula. I'd rather use calculator. I'd rather use me. But we can do quadratic formula if you want. Because the fraction, I don't know. Ready? Let me show you. Second calc. We're looking for the zero. Zero. Now remember this left down, right down thing?
Yeah.
We're going on either side of that zero. So you're just going to go on one side, hit enter. Go on the other side, hit enter. Yes, hit enter. The answer is 7. If it says arrow bound, you did it in the reverse order. It doesn't matter.
So the left side is the right side, and the right side is.
That's right.
Wait, so how do I-
Do it again.
How do I get the little thing, intersection?
No, not intersect.
Oh
It's not
my
two
God,
graphs.
We put zero.
Zero.
So what do I hit?
Second, calculate 0.
Oh, I got 7.
So if what if I went this way?
It would give you 0, 0.
Then I would have to go
It would go left, right, left, right. This is left, right.
Oh,
This factor.
Yes.
Look. Oh, it says left now, so I go to the.
You go to the left. The left is above the graph in this case.
I got it.
we're upside
We did it.
Here's where the left and right thing really creeps all up. Well, here's our graph, or at least a simulation of the graph. We're trying to find this point over here for when it hits the ground. Do you agree? Okay? So what I want us to do is I'm going to say, okay, this is the left. That is the left. Here. Okay? This is going to be the right. Okay? That is going to be the right in this case. Okay? Left, right. We could also do it right? Wow. If you do it backwards, it's not a big deal. The calculator will just say error bound. Okay, then just redo it the other way. It's not a big deal. Sure, I'll do it one more time. Let's go back and refresh our memory on this modeling stuff. Are we ready? It's really not as much work as you think. It's just because the first time we go through it, I have to go very slow to make sure you're not missing anything. So let's just refresh, let's retrace our steps. If you are being asked to find a model means what? Equation. You're going to be given either a table, a set of points, sometimes it's written in function notation, sometimes it's written as a mapping. You have x's and y's in each of those cases. You put them into stat edit on your calculator. Then you're going to make sure that you don't have anything in list 1 and list 2, and you're going to put them in there. Then to find the equation, you're going to go to stat calc quadratic, and it will give you the equation. Here's our equation. If we want to graph it, which is a good idea because to answer any kind of questions, you need the graph there. You go to stat plot and you turn it on. Stat plot is second y equals. You turn your stat plot on. You make sure that it looks like this. Make sure it's L1 to L2, and you zoom stat. Or you can zoom anything so you can see the top and the bottom. Okay? How do we feel?
Fire!
This boy is on fire! All right, Alicia. First you were
Get out.
now you're going to
Now he was the Whitney.
Wasn't that a film?
I know. That's what studying does for you. Okay? All right. So what I'm going to give you, I'm obviously we kind of run out of a little bit of time. That's okay. That's okay. Because you can take it home, but you only have a calculator. And if you have a calculator at home, that's great.
Give me some homework.